Okay, so we're going to look at some different types of slope problems that we could solve using the same slope formula. Okay, slope formula is up there in the upper right corner. Remember, you should memorize that. y2 minus y1 over x2 minus x1. So the first problem is we're going to find slope from a linear table. Okay, so now it's important that it specifies that this is a linear table. Okay, because in the next example, it's not going to. Okay, well, we have a table. We know how to find the slope from ordered pairs, and remember that a table is just a different structure for ordered pairs. So on this table we have 3 x values and we have 3 y values. To find slope you only need 2 points. Okay? So you're just going to pick 2 points from this table. It'll be your x1 and your y1 and your x2 and your y2. So what we could do is we just pick the first 2 points. Okay? Let's say x1 is negative 12, x2 is negative 9. Okay? And then if, remember they have to match up, so y1 has to be negative 11 and y2 has to be negative 9. Okay, plug them in. Plug it into the formula. M equals, slope equals, y2, whoops, I wrote y1, that should be y2, y2 minus y1. Okay, that's going to be negative 9 minus negative 11. Over x2 minus x1, negative 9 minus negative 12. And then simplify. Remember, minus and negative is the same as plus. So if you want to do plus and plus. So we're going to get negative 9 plus 11, which is 2. Negative 9 plus 12, which is 3. So our slope is 2/3. Now it said it was a linear table, so what that means is linear equations always have a constant rate of change, or the same slope throughout. So we could try another one. So it doesn't matter if you want to pick, okay, we pick the first 2. You can pick the second 2. Okay. We could try it with those values. You could even try, split the difference. Have your ordered pairs be the first ones and the last ones. Okay. So you could try each method of it. You should get 2/3 each time if it is in fact a linear table. So let's try it. Let's get rid of those. All right, let's do the same thing but focus on the bottom 2. Okay. Well, another way to find the slope is, remember, just changing y over changing x. So how are your y values changing? How do you go from negative 9 to negative 3? Well, that's a change in y of plus 6. Same thing on the x column, the change in x. How do you go from negative 9 to 0? Well, that's going to be plus 9. Okay. So what's our change in y over our change in x? Okay. Our change in y is 6. Our change in x is 9, which simplifies again to 2/3. Okay. And like I said, you could split the difference and try it with the top 2 and the top ordered pair and the bottom ordered pair. We'll get rid of that. What if our y2 was now negative 3 and our x2 is now 0? Well, you can do the same formula, and again, we should get 2/3 out because the constant rate of change, regardless of which 2 points you pick, will always be the same. So in this one, it would be negative 3 minus negative 11. For the y's, that would be the change in y's. And the change in x's would be 0 minus negative 12. Okay, so negative 3 minus negative 11. Negative 3 plus 11 is 8. 0 minus negative 12. 0 plus 12 is 12. And 8/12 simplifies to 2/3. Okay. So again, constant rate of change. Doesn't matter which points you pick in that table. If it's a linear table, the slope is always going to be the same. What if the table is not linear? Or what if we don't know if the table is linear or not? Okay. So this one we're going to determine if this table is linear. Now instead of using the normal slope formula of y2 minus y1, I'm just going to use the other definition of the change in y over the change in x, delta y over delta x. Okay. Now that change in y over change in x has to be constant throughout this table, okay, or the same ratio throughout this table. So they might not be the same values, But if we divide the change in y's over the change in x's, they should all simplify to the same number, if in fact this table is linear. So let's find the change in y's between each of these ordered pairs, between each of these x's and y's. Going from negative 10 to positive 5 is a change in y of plus 15. Going from 5 to 14 is a change in y of plus 9. And then going from 14 to 21 is going to be plus 7. Okay. Now those values aren't all the same. That doesn't mean this isn't linear, okay? Because it depends on how your x's are also changing. The x's, let's find the x change in x's. Okay. So going from negative 3 to 2 is plus 5. Going from 2 to 5 is plus 3. And going from 5 to 7 is plus 2. Okay. Now all those ratios of changes should be the same. Okay. So let's try them. Okay. Well, the first one is the change in y was 15 and the change in x was 5. Okay. So that's going to be a slope, a change in y over the change in x of 15 over 5, which simplifies to 3. Okay. Check the next one. 9 over 3. 9 over 3 would be your slope. 9 over 3 simplifies to 3. Okay. So far it's a constant rate of change. And try the last one. Okay. If this matches, if it's also 3, then it's going to be linear. If it's not 3, it's not linear. Okay. So we got a change of plus 7 and plus 2, and 7 over 2 is not 3. Okay. So this is not a linear table. These slopes are not the same throughout. Remember, to be linear, it has to be a constant rate of change, and these slopes are not the same. 2 of them are the same, but you do have to check each one to make sure. Okay. So this is not linear. The last type of problem we're going to talk about is finding a missing coordinate. These are my favorite types of problems with the slope formula. Okay. So this problem says find a value of x so that the ordered pair x, 3 and 7, 6 have a slope of 3. Okay. So usually we're using the slope formula to find slope. Okay. This time we're going to use the slope formula to find a missing coordinate. Okay. So what's missing here is we don't know what that first x value is. Okay. We don't know this x value. Okay. So we don't know x1. Okay. We know y1 is 3. And we know x2 is 7, and we know y2 is 6. Okay. We also know the slope, which is m, is 3. Okay. So if you think about the slope formula has 5 variables in it. Okay. It has m equals y2 minus y1 over x2 minus x1. Okay. So in a formula, if you know all but one of the variables, you could solve for that last variable. So in this one, we know all the variables except for x1. So we're going to use that formula and we're going to plug in those values. Okay. So wherever, we're just going to plug in what we labeled here. So m equals, so we know m is 3, so 3 equals. Okay. y2 minus y1. Okay. y2 was 6, y1 was 3. Over x2 minus x1. x2 was 7, and x1 is what we don't know. Okay. x1 was just x. Okay, we can label it x1. Okay. Alright, this is an equation that we can solve. Okay, because again, we're only missing one of the variables. So I'm going to clean up this equation a little bit first. Okay, on top I could do 6 minus 3, which is just 3, over 7 minus x1. Okay, so how can I solve this? Well, we've been solving problems with fractions before. If you have a fraction in the denominator, you should multiply by that denominator. What you could also do is you could cross multiply. Okay? So what we could do is we could rewrite 3. Okay, remember, we usually write slopes as fractions anyways. We could rewrite 3 as 3 over 1. And then cross multiply. So remember, cross multiplying is the top of the first times the bottom So that's going to be 3 times 7 minus x1. And it's going to equal the top, or the bottom of the first times the top of the second. 1 times 3. Alright, then simplify this and then we'll be able to solve. Over here we're going to have to distribute the 3. Okay, remember when you distribute you go to multiply both terms. So it'll be 21 minus 3x1. Okay, 3 times 7, 3 times x1. And on the right side, 1 times 3 is obviously 3. And then solve for x. This is a two-step equation. Two steps are going to be subtract 21 from both sides. Again, we're trying to isolate the x1. So subtract 21 from both sides. Leaves negative 3x1 and negative 18 on the right. And then your last step would be to divide by negative 3. So our x1 is going to be negative 18 divided by 3, which is 6. So if we plug 6 into that ordered pair, which was x comma 3, okay, again we were solving for one of the coordinates, 6 comma 3 and 7 comma 6 would have a slope of 3. Alright, let's try one more of these. This time we know the problem says that 8, 3, and 0, y2 have a slope of negative 2/3. Find y2. Okay. Well, same thing. We have 4 of the variables, and we're missing 1. We have x1, and we have y1. Okay. We have x2, and we're trying to find y2. Okay. And we also have the slope, which is m. Okay. So if I'm plugging these in to our formula, it's going to be 2/3, negative 2/3 for slope, equals y2 minus y1. Okay. y2 we don't know, y1 is 3. Over x2 minus x1. x2 is 0, x1 is 8. Okay. So we're just going to simplify this and solve. Okay. The first simplifying, 0 minus 8, we'll clean that up as negative 8. So we have negative 2/3 equals y2 minus y2 minus 3, okay, over negative 8. And then same thing as the last problem, we're going to cross multiply. Okay. Top times bottom, bottom times top. Okay. So it's going to be 3 times y2 minus 3 equals negative 2 times negative 8. Distribute and simplify, and then we'll solve that equation. Distribute the 3. 3 times y is 3y. 3 times negative 3 is negative 9. And then negative 2 times 8, negative 8 is positive 16. And solve for y. Add 9 to both sides, divide by 3. Leaves us with 3y equals 25. And then divide by 3. Okay. So this one doesn't get as nice of a solution. But again, all these equations only have one answer. So for those ordered pairs that were listed, for these ordered pairs to have a slope of negative 2/3, that means that y2 value, that second y value, has to be 25 over 3. Okay. So not a nice answer, but again, it's the only way for those 2 points to have a slope of negative 2/3. Okay, so like I said, those are my favorite types of problems when you're solving for one of the missing coordinates. Okay. So guaranteed to be on the next quiz and test.